In this video, we'll write unit tests and of course the two types of the unit tests, which are local unit tests and integration unit tests. Let's go to an empty Android Studio project. As you can see here, I have nothing on it. And let's go to Gradle because to write tests we need some dependencies first. So when you come here, you'll find that you already have some dependencies that don't just use this implementation function. Instead, they have test implementation and underweight test implementation. So we have two types of tests, which are those tests that run on the JVM, so they don't need underweight resources, and tests that need underweight resources and they run in an underweight device. These dependencies are for tests that run on the JVM, they don't need underweight resources, and these need underweight resources. So that's the difference, and you find these already there. Now what I'm going to do, as always, I just delete the ones that I already find and I paste my own ones. So there are a bunch of dependencies that we need. And here they are. So if you don't use version catalog, then you want to use these. If you use version catalog, then you want to use these. Now let me just go to my libs.version and then let me paste the versions as well. So right here are all the versions, and then let's paste the dependencies right here. Okay, so let's just sync the app and let's see them. So we have local tests and instrumented tests. They said local tests don't need underweight resources, instrumented tests do need underweight resources. So let's see them. JUnit is the core testing library of underweight. It's required. So this one is important to write tests. Truth is for assertions, so we want to assert that a value is an actual value that we want it to be. So let's say we want to validate something. Is that validation true or false? We want to use truth. That comes from, of course, Google. Okay, we have underweight Xcore, just more core testing libraries. So these are as well testing with coroutines, mock web servers. So this one is used to create a fake web server that we can use with our retrofit API. In testing, we don't of course want to access the real API in which we can get information, but we just want to create a fake one using this mock web server that creates a mock web server that just is fake. Mock creates again mock dependencies that we can use. So yeah, anything that we don't want to actually access in a test, we want to create a fake version of it using mock. And then this one shouldn't be here because it's already here anyway. So these are for the local tests. Now the instrumented tests, or the underweight tests you can say, so these need underweight resources. Again, more core testing libraries like JUnit, JUnit 4, which is library that we use for testing, Core for Kotlin, core testing, underweight X, all of these are just required for coroutines. Now again, truth for assertions, as we have that for normal local tests. Now we also need them for underweight tests, as you can see, because we also need to make assertions in just underweight. So let's say we click on a button to display a progress bar or a circle of progress indicator. So we make sure, is it really displayed, using truth that is used for assertions. So in here to just verify is a value, is what it needs to be here. For example, is a block of UI is actually shown in our apps. So because this is underweight test, okay? Expresso, which is used to actually test our UI. So how do we click on a button to navigate and all those stuff? We use Expresso to actually give commands. Click on this button, navigate, scroll, delete this item, swipe this item away, all of that. We use Expresso for that. Again, a web server to create mock web servers, mock to create fake versions of dependencies and classes that we use, and this one just for creating testing compose UI that we want to test with. And these are the same. Of course, we also have some Dagger dependencies, but in this video we won't need Dagger, so I just didn't include them in here. But as you can see, if you come here, you see that we have this capped underweight test that has Dagger in here and also Dagger. So we'll also see how to actually test with Dagger. Okay, and in libs.versions, here are the versions of local tests and versions of instrumented tests, and here are all those dependencies or libraries. So all you need is these for now. In the next projects, we will just add these two Dagger dependencies that we will also need. If you want to add them right now, feel free to do that. That's it, that's all we need. We sometimes also get an error that has to do with some license.md. I usually just paste those two lines in here to remove I don't really know what that error is, but these two lines fix that error. Make sure to use the latest Kotlin version. Let me just paste that as well right here, as you can see, because here I'm using what is that, latest version. So I just need to make sure that I'm also using the latest Kotlin compiler extensor version, and that's it. Actually, let's just sync the project. Let's build it, make sure that we have no build errors. Good, we have no build errors. Now let's actually start writing our first test. So let's go to our project here. In TDD, or test-driven development, we'll write the function signature but not the implementation, and then we'll write the test for that function, run the test, it will fail because the function is not implemented, then implement the function, run the test again, and then it succeeds. If it doesn't, we refactor, we change our function, and then run the test again, and so on until the test passes. We have a good working function. That's what we are going to do. We will use the test-driven development in this video. So now all we are going to do is testing a user registration in which they can enter an email, a password, a username, confirm password, all those 4 things. We'll write test to verify that those functions that validate this user input actually work properly. Let's start with validating our username. So let's create a package here. Let's call it unit test. Then we just bring this main activity to UI because we don't really need that. We're not building any UI in this app. Now the first validator that we have is validating usernames. So let's call it user name validator. Maybe name needs to be like this. That's going to be a class. Inside that class, we'll assume we have a list of users. So private val users is equal to list of username 1, username 2, username 3, and so on. So here we have a list of usernames, okay? Because later we will actually verify if the username exists in the list or not. Now let's create the function, but not the implementation, just the signature. So let's just create some space and then operator fun like this. It already completes for me. Invoke, pass in the username. Now we won't do anything, as I said. We'll write now the test case, but let's actually see the packages in which we can create our tests. Let's collapse this one now. As you can see, here is the package in which we write our code, which is something we are familiar with. But we have 2 more, underweight test and test. And again, in test, we write local test that don't need underweight resources. Underweight test, we write tests that need underweight resources. So right here, we already have an example. As you can see, this test just checks is 4 actually equal to 2 plus 2. And if that's true, then the test will pass. If not, it won't pass. Okay, but for now, we don't really need this test. Let's just delete it. And now let's see the second one, which is underweight test, in which we write tests that require the underweight framework resources or components. We already have an example again that just checks if the package name that we have in here as a string is the actual package name of our app. So to get the package name, we technically need context, as you can see. So this one needs to be running in this package that is underweight test. Again, we don't need this. We can just delete that. So in our test, that is username validator, we don't need any underweight framework thing. So to generate a test for that, it should be right here inside this test package structure because we don't need any underweight framework, so it needs to be here. So how do we generate a test for it? We just right click on it, we click on generate, and then test, we choose GUnit 4, that's what we use for testing. We keep the name username validator test because this one is called username validator, this one is going to be called username validator test. We click on OK, and then here, as you can see, we can either choose putting it in unit test or underweight test. But since this doesn't need any underweight framework components, it needs to be inside unit test. So in the second one, we click on OK, and here is our test generated, and it is actually generated in the same package. So as you can see, here is my core package unit test. The test is inside there. I mean, here the validator is inside this one, and then the test is inside this one. So it's better to keep the same package structure so we can easily find our tests. Now we don't need actually this one. Let's just delete it. And a test in the end is just a class in which we have functions that we run. So now let's create those functions. So right here, to create a function that is a test, so let me just get some space, we need to annotate it with test like this. That comes from GUnit, fun, and then we'll write the function name. And since this is a test function, we can just use these. I don't know what they are called honestly, but we can just use these two and then we'll write our function name inside it. That is going to be, in this case, validating our username. So we can write validate username, and with a valid username like this, and then comma, and then we'll write, let me just close this, we'll write what we expect this function to return. So this is what this test is going to be about, validating our username with a valid username. And then what do we expect if it's a valid username? We expect that the function returns true. The username is valid, so returns true, like this. So it returns true because that's a valid username and it's a function. So don't worry about the autocomplete. So right here we need to validate our username. So create a val is valid like this, and it's going to be my username validator dot invoke, and then passing a username like this. And then we want to assert that it's valid or not. So invoke, as you can see, doesn't return anything or is not implemented yet. And then we want to assert if our test passes or not. So assert that like this, and then we want to import it from truth, which is this one. So that's what we are going to use. Assert that is valid dot is true. So we want to assert that the result that this function returns to us is true. Now if we run our test, it will fail. Why? Because we have an error. The function is not implemented yet, as you can see. Now the test fails, so we need now to actually implement the function. So as you can see, we are already using the TDD approach, or the test-driven development. So we wrote the test case first, and then we want to implement the function. So when would our username not be valid? First of all, if it's empty, and then if it contains a space, so now it depends. In my username, I don't want any space. And then if it's already taken, if we already have a username here, of course we can also write if it contains special characters and so on. You can expand this as you want. In my case, I'm worried about these three things. So if my username dot is empty, then I want to return false. I don't want this. That's an invalid username. If username dot contains space like this, then I want to return again false. I don't want any space in my username. I want it to be like this with no spaces. Okay, we could possibly have an underscore but no space. And then if the username is already taken, so if, as you can see here, I have a users dot contains my username. If it does contain it, then I want to return false. I don't want it to be there. I want a new username. Okay, now these are the three negative cases that I want to make sure that my username is valid. Is not valid. And if all of these are false, then my username is valid. I can return true. Now I implemented my function. So what we do after implementing the function, we run our test again. Let's run the test. So to run our test, we can just click on this green triangle, or in this one. So this one, we run all the tests that we have. If we want to run a single test, we can click on this one, and let's do that. And as you can see, the test passes. So the username is valid, and that's because I passed a valid username. Now I want to just duplicate this function a second time, but now validate username with empty username. So like this, no username at all. Now we expect from this one to return false like this, and is valid is false because we expect it to return false. Now let's run this test. It should pass, and it did pass because the username is empty, and here we already checked that if it's empty we return false. Now we can just check the other case, that is with a username, let's say, that has space. Okay, so write user name with a little space in here, and that exactly should fail again. Should pass again because we want to ensure that it's false. So it should pass again, I'm sorry. Okay, and then the other case, or the last case in this test, is if the username is already taken. So with a username that is already taken. Okay, and let's get a username that is already taken. So username 1 or 2, whatever. So that's what we are going to pass. Now it should return false, that username is already taken, and as you can see, everything is great. And if I, for example, pass a username that is not already taken, that should not pass. As you can see, the test didn't pass because the username is not taken. Now what I can do is just run all my test cases in this username validator test. Everything passes, so the function is working just as expected. So that's for validating my username. Now we want to write validating password, but now we already understand how that works. So I'm just going to paste it and then explain it because that's going to be a lot of code to write. So I pasted the password validator. As you can see, it just takes a password and it's not implemented yet. Now, let's again create the test for it. So let's go to generate test, again password validator test, and then use local test or unit tests. Okay, here we have the class. We can delete that right here. And the same as our user validator test, we're just going to validate our password. And now before actually implementing our test, let's go back to our username validator. As you can see, in all these test cases, I needed this username validator. So instead, let me just actually create an instance of that. So private var username validator is going to be username validator like this. And now I can use this one in all of them. So let's just do that actually like this, and then replace it with this one, and then username validator. Now, like this, I'm using it. We'll actually see something called setup function, teardown function, but that will be in the underway test. So now let's go back to this one and let's implement it. But I'm not going to write all those functions again because to save some time, let's import assert that. And the same with the other test, which is username validator test. I'm just validating my name. If it is empty, then I return false. That's an invalid password. If password contains a space, as you can see, password space some numbers, then I don't want that. I return false. As you can see, I ensure that, or I assert that it's false. If the password doesn't contain at least 8 letters, here it only contains 5, I again return false. And I assert that it's actually false. If the password doesn't contain an uppercase letter, I again return false. And as you can see, pass doesn't have any uppercase letters, and all of those again are not uppercase letters, so I return false. If password doesn't contain, let me just get some space. If my password doesn't contain a digit, I then return false again because none of them is a digit. They are all just letters, and I return false. So these are all the negative cases, you can say. Now let's create the actual positive one by ourselves. So let's just actually copy one of these and let's reuse it. Test password is valid, returns true. So this is the positive case, and let's just copy a password from here. And to have a valid password, it needs to have at least 8 letters, at least a capital or an uppercase letter, at least a digit, and we seem to have all of those, so it returns true is true. So we assert that the result, or is valid here, that we get is true. Now if we run our test, it won't actually pass, so let's do that. As you can see, it won't pass because we did not implement the function. And let's do that. Again, the same as our other function, which is username validator. We want to validate our password like this. So these are the cases I already covered in my test cases. If the password is empty, I return false. It's an invalid password. If it contains a space, if it contains less than 8 letters, if it doesn't contain an uppercase, so if any of those letters in the password is not an uppercase, I return false. If any of them is not a digit, I return false. And if all of these are false, then the password is valid, so I return, in that case, true. If one of them is true, then I return false because the password is invalid. So that's now the implementation. After the implementation, we want to run the test again. So let's run that. And all our test cases pass. And I always love to actually, in this case, we enter a valid password and then we assert that it's true, or we expect that it would return true, but let's actually enter an invalid password in here. Now the first test, or this test actually should fail, as you can see, and let's run all the tests. That one failed, which is this one that we expect to return true, but it returns false because we passed an invalid password. And just to ensure that the test actually works as expected. Okay, so that's for the password. Now we understand how to write these unit tests in which we just test functions that we have in our code. So this could be any function like validators or formatting or whatever. So we just test it, we make sure that the function works as expected. The function doesn't have to always return anything. This function could be a function in our view model that loads data from a database or a repository anyway, and then it updates a state in our view model. We just call that function, which is something we'll see when we build our app. We call that function, and then we make sure that the state now has the data after loading it. So we don't have to actually always check what this function returns, because sometimes it doesn't return anything. Okay, so that's for the password. Now I want to paste the other one, which is confirm password, in which we just validate that our confirmed password is the same as our password. Okay, so it just returns if those are true or not. And now let me just paste the implement or the test. As you can see here, password and confirmed password are equal, returns true. So the same password, we expect it to return true. When they are not equal, we expect it to return false. As you can see, these are passwords that are not equal. We can even write something like 000 to make sure that they are not equal. Now let's run the tests, and they will actually pass because we already have the implementation. But in your case, always do the test-driven development approach that I did with these two first. Now I'm just pasting them to save time. Again, here you can create an instance of this and then use it if you want to, like I did in the username, creating an instance and then using it instead of just creating an instance for each test. Okay. And then the last one is an actual instrumented unit test. So a unit test that runs on the Android device. So these are now local unit tests. Let's close that and let's create a new package here called, let's call it Android unit test, or instrumented unit test for a better name maybe. Like this. Inside this one, we'll have an email format validator. So email format validator, that is going to be a class again, and it has an operator function invoke that takes an email of type string, and then it of course returns a boolean, and we won't implement the function yet. Now, why did I create it inside here? Because to validate this email, we'll use patterns that comes from the Android library, which means this test needs to be run inside this one, which is Android test package, because we'll use patterns that is inside the Android, that comes from the Android. Okay, so it could also need context. So private val context of type context. If let's say here I call some library or anything that requires context, then this needs to be inside this Android test package, which is for instrumented tests or tests that requires Android framework components. Okay, now we want to implement the function. Instead, we will first create the test for it. So generate test unit for email format validator test. Let's click on OK. Now we will choose Android test. Okay, because we need context and we need patterns. Let's do this. And the two functions I talked about earlier in this video are before and after functions, or setup and teardown. So we can actually create those. So add before, and we'll see why we need them. This one is going to be fun setup, and then add after fun tear down. Okay, so why do we need these two functions? Basically to set up stuff. So anything that we want to use in our test that we need to set up at the beginning of our test, before we run all our tests, we will need to set up some things. And this could be a DAO. So let's say we want to test functions in our DAO. This DAO just accesses a database and returns values from it, data that is inside the database. We first need to create an instance of our DAO. So we need to create that inside the setup function and then use it in our tests. But then after our tests finish, we make sure that our test either passes or fail, whatever. So after our tests finish, in which again we access the database with a DAO, we need to close the database, and that means we need to close it when our tests finish. So in the teardown function, this function is being called after all the tests are finished. So here we can close our database, we can release any resources, whatever, we can do that in this teardown function. And in this setup, we can start or initialize those resources that we need. Okay, and let's actually do that. So in this email format validator, we need a private late init var email format validator, which is this one, which is something we want to initialize here. So email format validator is going to be an email format validator, but that requires context. So how do we get the context in a test? So we write context is going to be instrumentation strategy dot get instrumentation. Let's import that and let's close this dot get target context. So that's how we get the context that we want to pass now. If we need the context in our test, This is how we can actually get it. As you can see, this is dependency that our test depends on, and this dependency itself depends on the context. So that's all going to be in the setup that we want to initialize the context, or we want to get the context and then want to initialize this. If this one for any reason has to be nullable, then in the teardown we may say now email format validator dot is equal to null again. So we just set it to null again if it has to be nullable, but in our case it doesn't. So we have this function, as I said, if we actually need to release any resources, close in a database, or anything like that. Now all we are going to do is run the test for our validator. So let's start with when our test is actually valid. So add test again. Now as the local test, we actually use these two commas, I don't know what they're called honestly, and then we'll write our function name just like this with spaces and then comma and then what we expect it to return. Unfortunately, we can't do that with an underweight instrumented test. We can't actually do something like this and then we write our function. Nope, we need to write fun and write our function name just as regular functions. So validate email with a valid, or just with valid email, for example, and then underscore, and then now we write what we expect it to return. So returns true like this, and then we open our function. So it's exactly the same that we did, but in here we use those little things in which we could create spaces in our function name. Now we actually can't do that. We can just write it as a regular function underscore what we expect it to return or what we expect the result to be. So we could write this one like this. And again, this doesn't have to be returned. So let's say again, the function in the view model that calls a function in a repository that returns the data from a database, and then we update our state. So we could say here load data from repository, and then what we expect is list state is not empty. So it always doesn't have to return anything. It could just be the state is now not empty, the progress bar is showing, we did navigate, so it doesn't have to return anything, but in our case now it does return. So to validate this, we want to now use our email validator. So we can write var is valid is going to be my email validator dot invoke passing an email. So with a valid email in this case, so this could be something like email at gmail, for example, or anything.com. So this is a valid email, and then assert that import assert from truth passing is valid dot is true. Okay, if we run our test it will fail, and let's do that actually. And I don't know where the emulator is, but let's just bring it here. Since this is an underweight test that accesses the underweight components, if we run the test, so what is that test? Here it is. It actually needs the emulator now. Okay, it's not just a test that runs on the JVM as the previous ones, it needs the emulator. So now what we are going to do is let's implement our function. So that is going to be return patterns like this. Let's import patterns. As I said, it comes from underweight, so this needs the underweight resources. The email address, let's just actually make this one smaller, matches email.matches. So this is how we verify the format of our email. Now let's run it again, and hopefully now it passes since we implemented the function. If not, we can fix any errors that we might have in the implementation. This test, as you can see, is going to be slow because it needs the underweight resources, and it did actually pass. So our function does actually validate a valid email, but does it do with an invalid email? That's the question. So validate email with invalid email. Now we return false, and then the invalid email could be an empty string and then is false. And let's just actually copy this again, paste it. Well, this one validates email with empty email returns false. So this is an empty email. Now the invalid email could be something, so but we don't actually finish. I don't know if this is an invalid email, but let's run the test cases now. With test cases, it's slow, but everything passes. You can see an invalid email is not complete, so it is returning false, and then an empty email. So actually in the formatter I can also, or in the validator I can also write if email dot is empty return false. That's something I should have done, but I didn't, so this could also be a thing. And let's run the tests again since we changed something in the function, and it does actually pass. So to make sure that our tests work fine, let's actually pass an invalid email in this function that expects a valid email, and make sure that the test does fail like this. So yes, the test does fail when we actually expect a valid email but we get an invalid email. Now let's run the test again, making sure everything is fine with a valid email, and it does succeed. So all our tests can be just run like this, and then wait and make sure that everything works fine after the format that we did in the function, and all our tests pass. So that's a unit test, but an instrumented unit test that requires underway the resources, which are context in this case and patterns. And this is it for this video. In the next video, we'll start building an app in which we'll have retrofit, Roam database, repositories, view models, navigation, and we'll use this test-driven development when we build that app. So every function will be tested before implemented, so we actually have a safe base that we want our function to be on. So if anything is wrong, then our test will detect that before we even continue it. Okay, so this is it for this video. See you and bye.